Hello friends, I, Dhairya Bhatia, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In this video, we are going to discuss a question of June 2011 Csir-Net Part C of Linear Algebra. But before that, let me share something with you that if you are preparing for Csir-Net JRF Mathematics 2021, then here is a good news for you. We are providing a complete material including test series and previous year questions that can help you score 140 and more in the exam. If you want this, you can contact us directly at dnamaths@gmail.com or you can click on the link given below in the description. Moving on to our question. The question is, let aij equals to ai into aj, where 1 is less than equals to ij is less than equals to b, where ai's are the real numbers. Let a equals to aij be an n cross n matrix. Then the options are A. It is possible to choose a1, a2 and an to make A non-singular. B. A is positive definite if a1, a2 up to an are all non-zero. C. A is positive semi-definite for all a1, a2, an. And the last one, D. For all a1, a2 and an, 0 is an eigenvalue of A. I would recommend you to pause the video over here and first try this question by yourself. I can also give you a small hint. You can try this for n equals to 2 or n equals to 3. Moving on to our solution. It is given that A can be written as x into x transpose. Now how can this be done? Just simply take x as a column matrix, then x transpose will be a row matrix, and you will get our required A, that is a1 into a1 up to a1 into an. Similarly, an into a1 up to an cross an into an. So once we have required our A, further we will assume it for n equals to 2. We get A as a1 a1, a1 a2, a2 a1 and a2 a2. When we simplify this, that is, we find the determinant for any choice of a1 a2 of A, we get a1 square into a2 square minus a1 a2 a2 a1, and that will always be equals to 0. Similarly, we have determinant of A equals to 0 for any n, whether it's 3, 4 or n, and you can simply observe that the rank of A will be 1. You can find it by yourself. So it is not possible to choose a1, a2 and an to make A non-singular, and thus option A is not correct. Remember, when you are attentive the question in part C, it is not necessary that you always find the correct answer, but you can find the incorrect ones easily. Moving on, but as we know that the determinant of A equals to 0 and the determinant is nothing but the product of eigenvalues, so 0 must be an eigenvalue of A for all a1, a2 and an, and this makes our option D correct, which says that 0 must be an eigenvalue of A. So option D is correct. Now we have to check whether A is a positive definite matrix or a semi-positive definite matrix. I know that you all know, but if in case you don't know what is a positive definite matrix or what is a semi-positive definite matrix, then the positive definite matrix is a matrix in which all the eigenvalues are greater than 0. Remember, greater than 0. And in semi-positive definite, all the eigenvalues are greater than equals to 0. That is, greater than equals to 0. Now here 0 is an eigenvalue, so definitely it cannot be a positive definite, but it will be a semi-positive definite for all a1, a2 up to an. And you can easily verify that once again. And so option B is not correct and C is correct. And so the correct answers are option C and option D. Thank you. And you can be a member of our social club and watch 240 plus videos on our YouTube channel and get a complete study material regarding any competitive exam of mathematics from our Telegram channel.